Okay, here's a quick question. How long is this brick? It's a standard size brick. You've seen plenty of them. So how long do you think this brick is? And no measuring. I'd say it's about the same length as my hand span, which is about 20 centimeters long. How tall is this door? Again, no measuring. How tall do you think this door is? It's a bit taller than I am, and I am 6 foot tall, which is 1 meter, 85 centimeters tall. So that means this door must be about 2 meters tall. How heavy is this bag of cement? And again, no measuring. It's about as much as I can hold comfortably, and it is 10 kilograms in weight. When estimating weight, it's useful to remember that a bag of sugar weighs 1 kilogram. Imagine a fly wants to get from this corner to this corner of this block. What is the shortest route it can take? The block's dimensions are 45 centimeters by 20 centimeters by 10 centimeters. One obvious route the fly can take is to go across the block and down. We can use Pythagoras to work out that distance because we have got a right-angled triangle and we know these two are the sides, but I can measure it. And it's 50 centimeters plus an extra 10 centimeters down this side, and that gives us 60 centimeters in total. But there is a shorter route. Place your bet on a net. This is the net of the block. It's the surface of the shape when opened out flat. Now we can see that if the fly wants to get from this point to this point, we can go across the block and down. But this is not the shortest route. There is an even shorter, more direct route from this point to this point, and I can measure it. And it measures 59 centimeters across. But there's an even shorter route. So on the net, see how this point here is also the same corner as this point here. So we've got an even more direct route from here to here. And I can use the tape measure to measure it. 55 centimeters long, which is even shorter. And I can check that using a piece of string. I can go diagonally across the block and down, or I can go across the block and down the side, which is even shorter. This architect's drawing is done to a scale of 1 to 50. And on the plan, this room measures 5.4 by 4.6 centimetres. What length of wooden skirting board do I need to go right around the room, ignoring the gap for the door? Wooden skirting board goes around the edge of the real room. That's the perimeter. So first we need to work out the perimeter of the room on the plan. That's 5.4 centimetres plus 4.6 centimetres plus 5.4 centimetres plus another 4.6 centimetres. And that's 20 centimetres in total. With a scale of 1 to 50, the perimeter of the real room is 20 centimetres multiplied by 50, and that's a total of 1,000 centimetres. And that's 10 metres of wooden skirting board. Back to the plan. What area of carpet do we need for the real room? Remember, the scale is 1 to 50. The area of the room on the plan is 4.6 centimetres multiplied by 5.4 centimetres. That's 24.84 square centimetres. The scale of the plan is 1 to 50. So what is the area of the real room? One thing's certain, the area of the real room isn't 50 times the area of the room on the plan. The scale of 1 to 50 refers only to the lengths. So we need to convert the lengths first before working out the area. Here's one for you to try. The sides of this smaller tile are 2/3 the length of the sides of the larger tile. What is the ratio of their areas? Here's a length of wooden dowel with a circular end. How can we work out its volume? The volume of a shape like this, with its cross section the same all the way through, is the area of its end multiplied by the length. But first we have to measure accurately. That's between 2 and 3 centimetres. But first we need to look at the smaller divisions on the tape measure. So we've got 24 millimetres or 2.4 centimetres or 2 centimetres and 4 millimetres. And now let's measure the length. The other end reads over 200 centimetres. In fact, it measures 244 centimetres, which is the same as 2 metres and 44 centimetres. Now we know the measurements. What's the volume? The volume is the area of its end here multiplied by its length. But watch out, we can't mix units. That is, millimeters, with centimeters and meters. So on this occasion, we're going to use centimeters. So let's work it out. The volume is equal to pi times the radius squared, and that's the area of the end multiplied by its length. That is 3.14 multiplied by half of the diameter, which is 1.2 squared, times the length, which is 244 centimeters. That is 3.14 multiplied by 1.2 multiplied by 1.2 multiplied by 244 gives us a total of 1,103.27 centimeters cubed. Here is a pile of bricks, and each row has one brick more than the row above it. How many bricks will I need for 10 rows? If I want to work out how many bricks there are in 10 rows, I have to add up all the numbers from 1 to 10. That's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and that equals a total of 55. Now that didn't take too long, but what about the number of bricks in 100 rows? Instead of adding all the numbers from 1 to 100, I can do it in a much simpler way. I can add the first and the last number, and that equals 101. The second and the one before, that's 2 plus 99, and that equals 101. The third plus 98, and that equals 101. So, in 100 rows, there are 50 pairs of numbers that total 101. So the total of all the numbers must be 101 multiplied by 50 pairs of numbers equals 5,050 bricks.